All right, question 29. We have this table. We have 2 to the x power. So we have function, we have y-axis symmetry, origin symmetry, domain, and range. I guess we can tackle the domain and range first. I think that's a lot easier. So first, let's look at the domain and range for each function. For the first one, it's to the x to the 4th power. If you can think about the graph, it's going to be like this. Okay, it's very similar to a quadratic. It's with the only exception that right around the vertex is a little bit flatter. And if you know how to sketch it, I would say you can also tell that it's a y-axis symmetry and not an origin symmetry. The domain, it's going to be all real numbers, meaning that it will go from negative infinity to positive infinity. If you know how to sketch it, which you should know how to sketch it, the range, it's going to be 0 to infinity. And it includes 0, so with a bracket 0. Okay, with bracket 0. Now, for the next function, it's a rational function. It's 2 over x. It's 2 over x. So the domain is everything but 0, because you don't want to have a 0 in the denominator. So the domain is going to be negative infinity to 0, not including 0, union 0 to infinity. Right? And for the range, now let's see if you know how to sketch it. So for 2 over x, the sketch is going to be like this. Okay, I hope you know how to graph 1 over x. So 2 over x is going to be something similar. There will be a horizontal asymptote of 0 and a vertical asymptote at x equal to 0. So that would guide us through our range. And in this case, well, it is impossible for the y value to be 0, since for y to be 0, the numerator must be 0. But since the numerator is a 2, which can never be 0, so we say the range, it's going to be negative infinity to 0, union 0 to infinity. Okay, so so domain and range, they look identical in this case. Okay, you squeeze them together a little bit. All right, then what about the next one? This is a 5th root. Okay, now if it's a square root, then we don't want anything underneath the we don't want anything negative underneath the square root or even number root. But if it's odd number, well, oh, hold on. I forgot to answer the symmetry question of the previous one. In this case, it is clearly not for the rational function. It's clearly not a y-axis symmetry. It is clearly an origin symmetry. Okay. What else? Y equals to negative 2 to the 5th root of x. So it's an odd number root. So that means it's okay to have negative number. So for the domain, there is no restriction, since any number works. And since any number works, if you know how to sketch it, then you will find out that the range would also be all real numbers from negative infinity to infinity. Now, what is the graph going to be like? It looks something like this. It looks something like this. Okay, so that's the general shape. And I know this because I know that a cube root, it's a function that looks like this. So it's like a square root function, but then you do have the other half in the opposite quadrant. Okay, so so if it's a negative, if there's a negative sitting in the front, so that means you have a reflection over the x-axis. Now, if you say, well, what if I don't know? What if I don't know how to graph? What if my mind just not be able to recall the shape of these graphs, how can I tell the symmetry? How can I know if it's a y-axis symmetry or origin symmetry? Well, not sure if you were able to recall a couple of terms. When it's called the y-axis symmetry, it's also known as even function. If it has an origin symmetry, it's known as an odd function. If you're going to calculus, these two terms are pretty important. And the definition of even function is that f of negative x, meaning that if you have the negative x value, well, if it's reflected over the y-axis, then it should have the same y value. So that's why we say f of negative x, it's equal to f of x. An odd function is that when you go to the other side of x, well, you go to the other side of the the y value too. So that's why we have f of negative x equals to negative f of x. Okay. All right, now in class, I also ask you all to do something, which is that I ask you all to draw an x squared function and an x cubed function, because those are really good anchors to show you that, oh, what's an even function and what's an even function and what is an odd function. So let me just go ahead and do this very quickly. So if you have a square x squared, it's like this, and x cubed is like this. So there's no way you don't know what even function looks like. There's no way you don't know what even function means. So as the odd function. Okay. So if you say, all right, what about this one? Well, go ahead, make this like a function notation first. -2, fifth root of x, and then go ahead, put in a negative right here. So it will turn out to be a negative fifth root of x, because the fifth root of -1 is -1. So you end up with 2 fifth root of x, okay, which is the negated version of f of x. So that's how you know it has an origin symmetry and not a y-axis symmetry. Now, if you find this a little bit too complicated, I have another option for you. You may say, well, let's go ahead and find out what f of 1 is. F of 1 is, well, f of 1 is just -2. And then you ask, what is f of -1? Well, in this case, I hope you know how to handle fifth root of -1. That would give you -1, which gives you 2. And this will be an alternative way of seeing that it is an odd function, because the y value, it's negated. Okay, so you have a lot of tools at your disposal to find out these even function and odd function, y-axis symmetry or origin symmetry.